Hi, my name is Erin O'Meara, and I'll be walking you through how the accelerometer sensor works. So a little bit about the sensor. The accelerometer measures the force in the X, Y, and Z direction. On our Lunasat, we have the MPU-6050 located on the backside of the Lunasat. So the MPU-6050 specifications, the interface that the sensor has is I2C. Full specs can be found on InvenSense datasheet, but some highlights of it. The range, which is the minimum and maximum that can be measured by the sensor, is positive, negative 2, 4, 8, or 16 Gs. As for the accuracy, this is how close the sensor can get to an expected truth value measured. For instance, the acceleration of shallow moonquakes observed by the sensor versus the expected. This can be positive or negative 3%. As for the resolution, this is the smallest change that the sensor can perceive. This one can be 61 micro-Gs per least significant bit. As for bandwidth, we have 1000 Hz, and for noise, we have 400 micro-Gs per square root Hertz. So some fundamental principles behind the accelerometer. Take, for instance, the glass of water sitting on a table. You hit the table, and the water in the glass will move. Have you ever wondered why? Well, this is because of Newton's second law. These same principles apply to the accelerometer. So diving into Newton's second law is force equals mass times acceleration, where acceleration is calculated by measuring a force applied to a known mass, as shown in the diagram below. As for Hooke's law is similar, where it's force equals negative spring constant times displacement and distance. Force is calculated by measuring the distance the spring has stretched from equilibrium, as shown in the diagram below. As for capacitance, capacitors are parallel plates that store energy in the form of an electric field. Capacitance equals epsilon times area divided by distance. The distance is calculated by measuring the capacitance of a capacitor with a known area and dielectric. Epsilon is the value of permittivity of the material between the plates. So how does the accelerometer work now that you know the fundamentals? Well, spring displacement to measure the force of acceleration takes place. If the sensor experiences a force, the mass will be displaced by a proportional distance. This displacement is measured as a change in capacitance. This new capacitance tells us about the forces on the sensor and therefore about its acceleration. So as a summary for how the accelerometer works, force produced on the moon, such as a moonquake, a meteor impact, etc., the Lunasat moves as a result of this force. Microstructs in the sensor will move with the Lunasat. These movements will change the capacitance of the sensor. Capacitance change creates a voltage change, and voltage change is measured by the sensor. This voltage change is translated into a force, which we can use to find acceleration since we know the mass of the Lunasat.